In the middle of a project about measuring nanocurrent, it became apparent that my lab bench power supplies that I've been using aren't that flash. They've been sort of this style, which is convenient. So a little lithium cell and a little buck boost converter stuck on the end, and yeah, quick and dirty, all good, but lots of ripple, lots of noise, not that accurate. And in general, I felt more and more need lately for a power supply unit that's actually going to do some of the things that I'd like to do. So it starts with this guy here. So this is, I don't know, this is a ginormous power supply. So going from AC to DC. So the stats on here are something like 19 volts and 7.1 amps. So it's huge and heavy. I don't need 19 volts and 7.1 amps, but yeah, I do like to have that headroom, I suppose, for perhaps what might happen in the future. So my plan was to take the AC to DC out of this and then feed this in, and rather conveniently, I just happen to have these female jacks here which fit the output from this monster, and so I'll put it into a breadboard here and feed it directly through to an LM2596. Now we have seen an LM2576 on this channel before, and this is practically the same really. I guess the only difference is that I can tell is that it's operating, they're both switching regulators, but this operates at a much higher frequency. I think it's around 150 kilohertz. And as well, it needs a smaller inductor. So this is 33 microhenry compared to, I think it's 100 microhenry for the 2576. And this is a 220 microfarad capacitor instead of, I think it's 1,000 microfarad for the 2576. So the 2596, and really all I'm going to do is switch it down to somewhere of the order of, let's say, 8 volts. So we'll do that first, and then I'm going to take that further and put it into a linear regulator. And again, just for proof of concept, I'm going to use a 5-volt linear regulator, probably the L7805, and then that should give us a nice stable 5 volts from this monstrosity that we can use for the basis of a lab bench power supply unit. So just a quick explanation of the circuit. There's more information on the blog and indeed the data sheet for the LM2596. But I'm going to plug this straight into this rail here. It's not connected to the bottom rail at all. And the red wire that you can see there plugs into pin number 1 of the LM2596. And then there's a couple of capacitors coming out of that. One comes from pin number 1 and one comes after we take pin number 2, the output via this 33 microhenry inductor. And then there's a couple of pins which there's a ground obviously, but there's also, one of the pins is tied to ground to actually enable it. So you can, through a microcontroller, turn this on and off, which is an interesting feature. So yeah, eventually it comes out to this pot, and I've separated this well out to the side here, and you've just got a fixed resistor, and then you've got this variable resistor, and that creates this voltage divider which feeds back to pin 4, which will determine ultimately, coming out of this rail here, what is the actual voltage. But just before we do that, I've got this little indicator, not accurate by any means, but just to see what's going on. I've got this plugged into the rail that the voltage straight from the power supply comes out. So let's try that. And yeah, not only is it quite high, around the 19 volts, but it is all over the shop. So that's one of the things which I'm hoping to avoid. How a computer puts up with that, I don't know. Presumably there's something inside similar to this setup to even that out. But if I take that and I put it into the output, then you can see that that's reasonably steady around the 9 volt mark. And we can affect that through the pot, and I hate these little pots. But let's just get that down to around 8 volts. So yeah, that's about maybe about 3 volts above the target voltage, which is 5 volts. So I'll go on now and I'll put the L7805 in here, and then hopefully we'll get a nice steady 5 volts out of that as well. Okay, so we've got our L7805 here. Output to this bottom rail here, there's a common ground now that I've added on there as well. So I'll just plug this in, and it should still be around the 8 volts that we had dialed up before. But now if we swap this over to the rail, it should be around, well, it should be exactly 4.75. Disappointed. So now I'm wondering if maybe it should be a little bit more than 8 volts, so that you've got enough to work with when you are regulating that voltage. So let's go back to the 8, and we'll bump that up by another volt or so. So around the 9 volt mark. There we go. So we're coming in from 20 volts to 9 volts, and then down to, wow, so there you go, 4.77. So much for the L7805. I'm going to go grab another one of those and just see if it is a localized problem with that IC, or whether there's something in the circuit I need to be looking at. Maybe a little bit of investigation needed to be done. These are from the same batch of 7805s. I think I've got another batch somewhere, so I might swap those out. In the meantime, I thought maybe there's something wrong with the circuit behind it, but in fact, the HT7350 that we've seen on this blog before seems to be presenting with a pretty stock standard 5.02 volts from the same source. So I'd probably have to say in the end that it's these guys here that are underperforming, and that's sometimes typical when you buy on the cheap, that the chips that you get are maybe the ones that didn't quite make the cut, and they've been shipped out to some, poor unsuspecting hobbyist in Tasmania. But apart from that, that is the circuit working, and I think the next step is to maybe replace this guy, the switching guy, with one of the more commercial versions, which includes protection and current limiting and all that sort of stuff, before we go on to the the linear voltage regulators. But I'm definitely going to have to dig out different versions of these guys to make sure that I can actually get 5 volts when I want it. See you next time.